All right, so we're going to continue using properties of rational exponents and radicals. Your warm-up today says simplify the following expressions. So what did you have to do for all three of these? What was the common thing? How did you simplify? You had to combine like terms. Okay, so in part A, what did you combine together? Okay, and that gave you negative 5x, and then my y's, which gives us negative 3y. All right, how about part B? What's my like terms? There you go. How come that piece in the middle didn't get included? It also has a y, which kicks it out of the party. It's not allowed. All right, 6 plus 8 is 14. But it's still part of your equation, okay? So don't, like, drop it off completely. It's still there. It just didn't get combined with anything else. All right. And then this guy. What'd you put together? All right, so when you put together the t to the power of 5s, my 3/4 and my 2, you had to add them. So you had to do what to your 2? And I need to make it have a denominator of 4, right? So how can 2, okay, you go make it 8 over 4. Yeah, so it's 11 over 4, t to the power of 5. And then we have 1 minus 3, which gives me minus 2. Okay. Don't forget standard form with these. Your exponents, highest exponent degree first. It also goes in alphabetical order. So that's why in part B, x squared by itself is first, and then x squared y is afterwards. The same thing with part A. That's why it goes x and then y. It goes in alphabetical order. Yes, remember? Yeah? Cool, because guess what? Radical expressions with the same index and radicand, they are considered to be like radicals. Okay? Remember, your index is the root. So they have the same root. Okay? And the same thing under the root, then you're able to add what's outside of the radical symbol. Okay? So like part A right here, if I have 5 times the square root of y, plus 6 times the square root of y, guess what? That's 11 square root of y. Okay? Because they both had square root y. That's like them both having the same variable. Okay? So they're gonna act the same way. Okay? My properties still apply. So in part B, I have exponents. We still have exponent rules that we went through a little bit yesterday. Before I can put anything together, because I can't right now, I need to do some simplifying, specifically on the right-hand side. Okay? I have a parenthesis being raised to another exponent of 1/2. So that's when we were able to distribute. It was the power of a product. That power of 1/2 to both pieces. Okay? So we have 9z to the 1/3 minus 3 times. This is 4 raised to the 1/2. And z raised to what? The 2/6? Do we agree? 2/3 times, because power to a power, we get to multiply. 2 times 1 is 2. 3 times 2 is 6. All right, we can do some more simplifying. Can you simplify 4 to the 1/2? A power of 1/2 is the same thing as a square root. So is there a square root of 4? Yep, it's 2. So don't forget that. Power of 1/2 is the same thing as square root. Power of 1/3 is the same thing as cube root. Right? Power of 1/4 is a 4th root. So we are able to simplify 4 to the 1/2 because that's saying the square root of 4. And then z, we can simplify its exponent. Instead of 2/6, we can put 1/3. Now I can multiply both pieces by my 3. So that's going to give me what? Negative 6z to the power of 1/3. Now can I put these two together? Yes. Now, after simplifying, they both have like terms. They both have the same base of z and have the same exponent of 1/3. So I can subtract 9 minus 6 and we get 3z to the power of 1/3. Okay, so if they're not given to you already with like bases or like radicans, there are ways to simplify it and see if we can make it happen. All right, that was add and subtract. Ready for multiply and divide? How about now? So with multiplying and dividing variables, do they have to be the same variable to multiply and divide? No. So that rule does not apply when it comes to multiplying radicans, okay? What has to match is the index, okay? So that's the one rule when it comes to multiplying and dividing radicals. Their index has to be the same. And as long as their index is the same, you can multiply or divide whatever is inside to each other, okay? So we're going to multiply, and we're going to also remember how to simplify, which we did towards the end of yesterday. Okay, and it says assume all variables are positive, so because of that sentence, I don't have to do the whole absolute value thing that we did, the very, very last thing we did yesterday. Okay? So this whole first problem, it's multiplying two radicals with a root of 4, or an index of 4. So I could put them all together under 1, okay? So I'm actually going to split them up with the 16, the A, the B, and the C, having each their own 4th root is how I'm going to set it up. Okay, so I have the 4th root of 16 times the 4th root. I have A squared and A to the 5th. So when I multiply those together, that gives me A to the 7th. Then the 4th root of, I have B10 times B, so that's B to the 11th power. And then the 4th root of C to the power of 4. As long as they all have the index of 4, you haven't changed the problem. You've just rewritten it. Okay. Can we do the 4th root of 16? Is that a thing? Yeah? What is it? 2. Yep, there we go. Good. Now the next thing we have exponents, right? We kind of dabbled on this yesterday, but we didn't dabble when it wasn't like a perfect even number. Like my last one, 4 over 4 is 1. We know that these cancel each other out. We know this part's going to be a C, right? We did not explore yesterday what happens when they don't divide evenly, like 7 divided by 4, 11 divided by 4. Rewriting that really isn't going to help me right now, okay? But I can separate them to make it happen for me. Do we agree that I could split apart A to the 7th as A to the 4th and A to the 3rd? Is that technically the same thing? Yeah? And why would I do that? Yeah. One of them cancels out, right? So one of my A's breaks out, but I do still have A to the 3rd still stuck inside. So how could I break apart B to the 11th? What exponents would help me out here? Think of your highest multiple of 4. What could go into 11? 8 and 3, right? That's helpful. So what gets to break out of the radical? A b squared this time. My first one, 8 divided by 4, that gives me b squared, right? The second one, though, 3 over 4, that's not going to simplify. So that's going to stay the 4th root of b cubed. Whoa. So I separate them, I simplify each piece. Now I'm going to put together everything outside of the radical and put together everything inside my radical. So outside of my radical, we're going to have a 2, an a b squared, and a c. Inside of our 4th root, we still have a to the power of 3 and b to the power of 3. Like that. So a lot of stuff being put together for that one. Do we have any questions on it? Okay. Here we go. Part B, it's another multiplying one. They both have what index? An index of 6. So we can treat it the way I just treated the last one. Okay, so I'm going to give each one its own radical 6. Okay, 36. So we have the 6th root of 36. I have the 6th root of, I have P6. There's no other P, so P6. I have the 6th root of Q7 and Q. So what's going to go in here? Q8. And then the 6th root of, I have an R squared and an R8. So that becomes R10. Good. Now, so we've broken it all up. Now it's time to simplify the pieces if I can. Okay? Is there a 6th root of 36? Is there a number multiplied itself 6 times to give you 36? 6 times itself twice is 36, right? But not 6 different times. There is no 6th root of 36. That's going to be pretty. Okay? There's also no perfect powers of 6, because if we do 2 to the power of 6, it is what? 64, I believe. So there's nothing that can be done. This is as simple as it's going to get. Okay? And that happens sometimes. Don't think it has to simplify. Okay? You have to check. This one does not simplify any further. Because we could break apart 36 as 6 times 6, right? Which is 3 times 2 and 3 times 2. I can't break those numbers down anymore. There's not a 6 of the same number. I can't do anything with it. Okay? So it's as simple as it's going to get. How about the 6th root of p to the 6th? That's nice. It's just p. Because 6 can divide by 6 and give me a nice 1. For my q's, if I do 8 divided by 6, do I get a nice whole number? No, I do not. So that means I'm going to have to break it up. How can I break apart the q's to give me something that adds to give me 8? 6 and 2. Because what gets to break out of there? A q gets to break out. Yeah, because the 6 power 6. Yep. But the 6th q with the power of 2 is still stuck inside. All right, how about the r's? How are we going to split those up? Because 10 divided by 6 is not a nice number. 6 and 4. Okay, so how does that piece simplify? Yes. Good. So because our root and my radical match up with this one, because 6 divided by 6 is 1, that's where the r comes out here, and we're left with r to the 4th still inside. Does that make sense on how that's happening? Okay. Here, this 6 divided by this 6 gives me this guy, because that's an exponent of 1. 2 over 6 does not simplify to a whole number, so that's why it's stuck inside. 4 over 6 does not simplify to a whole number, so that's why it's stuck inside. All right, so let's put all the pieces together that are not under the radical. What are those pieces? There's a P, there's a Q, and there's an R, yep. And then what are all the pieces that are inside the radical? Alphabetical order, yep. And the coefficient does come up front. So 36 Q squared r to the 4th. I didn't. I don't know what you're talking about. It's definitely a 6. We okay? Okay. Two mas. We can do it. So we've added, we've subtracted, we've multiplied. Only thing we got left to do is divide. Okay? I have a radical one and I have an exponent one that we're going to work with. Okay, so I have x divided by, I'm going to change my color. Let's do this one. Oh, purple. We have x divided by the cube root of y to the 8th. Okay? I'm going to rewrite it as a fraction. This is what I'm going to do. Can I do 8 divided by 3? No, I can't. Oh. But what if the 8 was a 9? Then could I do it? That would be so nice. So, like, could I bring in another one? I only need one more, right? I can, as long as I do it to both pieces. Okay? So this ties into rationalizing the denominator. Okay? I have 8 y's right now. That almost divides by 3 evenly. If I had one more, that'd be wonderful. And guys, so I'm going to bring it in. So my numerator is now going to be x times the cube root of y. And our denominator, there we go, is now the cube root of y to the 9th. And that's what we like. Because then can I simplify my power over my root? The cube root of y to the 9th is going to turn into what? Y to the power of 3. Okay, that's how we brought one more in, because 8 can't divide by 3. But 9 can divide by 3. And when I do divide it by 3, I get y cubed. Numerator is still x times the cube root of y. Bless you. Wake up. So with division, you can kind of alter and like make it happen for you. Multiplying, you gotta work with what's been given to you. Division, you can bring stuff in to help you out, as long as you bring it to both pieces of your fraction. Yes.
The next problem, is that supposed to be z minus 6?
I'm not even there yet, friend. It is an exponent of -6. Z, yeah, I know. It looks weird. It's z raised to the -6 power is what it should be. Yep. Yep. Somebody might have pushed the wrong button. Or maybe I didn't raise it up before I pushed the minus sign. But yes, this one is, and I'm going to do like last time, go ahead and put it into a fraction. So yes, my numerator is 14xy to the 1/3. Our denominator is 2x to the 3/4. And then z to the -6. So that is what it should look like. Okay. This one, I got multiple pieces, right? I have coefficients, I have x's, I have y's, I have z's. So like I did with my multiplying, when I had a bunch of different variables, I gave each one its own radical, right? So here I'm going to give each one its own fraction. Okay, so I'm going to split them up. I have 14/2. I have x over x to the power of 3/4. I have y to the 1/3. I don't have one on the bottom. I don't have a z on top, but I do have a z on bottom. Like that. So I'm just going to give each one its own fraction and then simplify each piece. Okay. Can you simplify 14/2? Yeah, you can. Yes, it is 7. My next fraction has a 2 like bases being divided. What do you get to do with our exponents? We get to subtract them, right? Yeah. So what's technically my exponent up top? That's a 1. So when I set it up, I'm going to do 4/4 minus 3/4. My next fraction cannot simplify. My last fraction with my z, what does that -6 tell us? Yeah, well, it already is a fraction, right? So if it's already been bumped down, now we're going to flip it up, bump it up. So now it's z to the +6, and it's not in a fraction anymore. Okay, so our final answer will be 7. 4 minus 3 is 1, so we have x to the power, to the power of 1/4, y to the power of 1/3, and z to the power of 6. Ta-da! Alright, so yesterday and today came from the same section in the book. So if you want to staple them together, or obviously just make sure that they stay together in your binder, okay, you'll use yesterday and today's stuff when you do the 5-2 assignment on big ideas. Okay, so for the rest of today, you're working on either 5-1 or 5-2, and then we can spend tomorrow working on it as well.